Hi guys, I thought I'd come back and explain some things to you about Laser Saber's unique little, what he called an air battery, which is really not an air battery, and it's really not a battery. And the thing about this cell is that when you use a carbon pole, or anything that's not real porous, you're going to notice that it's going to want to die on you. Okay, so the deal is you pull it out, and you can see the circuit's running. And actually, I've done this a couple of times already, so this isn't going to, but I will explain it to you. If you grab it like this and squeeze it like this, watch the LED. It's getting brighter, see? And the reason that that's getting brighter like that is because I am breaking up the gas bubbles that cannot get out of the carbon. I'm going to explain something to you. I'm not going to call it a battery, because it's really not a battery. I'm going to tell you where the energy is coming from all the experimentation and talking to several different engineers on what carbon and graphite actually can do. So if you just do this, your battery will come back and it'll stay that way. And then don't add too much moisture, just what you see in here, just this little bit of fog is all you need, and it'll just stay running for you like that. Now, what you want to do, what's really important is, if you're going to use this type of cell, and we're just going to call it a cell, we're not going to call it an air battery, because that's not what it is. There's no air being used up in here at all. The two things that are happening in here are, one of them's oxygen and the other's hydrogen. So here's what's happening inside here. When I squeezed it like that, I broke these gas bubbles. By doing that, I freed up the ionic transfer in thermal differential. There's a thermal differential going on here. So when you look at his big battery, I don't have to squeeze this because it's using graphite. So don't believe me, do the test yourself. Measure this in an ambient temperature room. You'll see that this is close to ambient, and you'll see that carbon graphite is 3 or 4 to 5 degrees cooler. The reason for that is the gas that's being generated in between the magnesium, the paper towel, is being absorbed through little nanotubes in the carbon graphite. And as it goes up to the surface, it creates a thermal effect, which is cooling, which is a negative resistance. So this is actually a negative resistance cell, and it works on thermal difference. That's where the energy is coming from. It's the difference between hot and cold. So if you can use the difference between hot and cold, then you have power like this and current. You see, you want to make all your circuits work on about 5 to 6 milliamps if you're going to use this cell, because you only got the little bit of difference in temperature. Now, if you put salt water, yes, then you're going to get a battery. It's going to make a real battery, and you're going to eat the magnesium off, and then the battery's done. You have no more life left in it without changing the magnesium. So the idea is to make circuits that run in the range on that thermal differential. And believe me, it's real energy. It's really a negative effect, and it can be proved out because all the tests say so, that this is actually one big thermal negative resistance, and this, when you touch it, is far colder than what the outside temperature is here. Now if you heat these to the same temperature, which I found out, what'll happen is it'll just start to go away. So you need the effect that's going on here. That's why it's operating like that. That's why you want to put a little bit of water down here, is the evaporation process. See, the coils are what really help here, but the same thing can be done if you'll hollow this out and get a big magnesium stick, and that will become your negative, and then you'll just move this over, and then you make this bigger and you put the stick down in there with a piece of felt at the bottom, and then what will happen here is you fill this with sand, and you'll actually have this thermal battery that'll work and work and work and work and work as long as you can keep the differential up. Now I've had these down at about 30 degrees. I've left them outside to where they almost freeze, and they still operate because they cause a differential in here, and that's where the energy is coming from. It's coming from the differential between hot and cold, and that's what my instruments are measuring, and I can only go by what I'm measuring and what I'm looking at. But it's important to make circuits, if you're going to use this kind of stuff, that will run on these small differential currents. It's really voltage, it's there, but it's not what you would term high output, unless, of course, that you put this in a solution to where you're going to evaporate one of the electrodes, and then you're going to get the real chemical reaction. As you can see, my magnesium has not oxidized at all. It's turned a little black from the graphite down here, okay, but I don't have to squeeze this because the graphite's doing it for me, and boy, you can measure this effect. You can use thermal probes and measure the exact same thing that I did running these circuits. So what you have here is a energy generation, that's done through the difference in degrees. So one is warm and one is cold, and the effect is electrical power. So thanks for watching. Hope it helps.